binary tree data structure. What exactly binary tree data structure is all about. So please remember the definition for true marks. They will give you this tree and they'll ask you to find out what type of tree it is. A binary tree in which every internal node has got exactly 2 children's. Binary tree representation. When it comes to the binary tree representation, I can also represent the binary tree using arrays and linked lists. Hello everyone, I welcome all of you to yet another interesting session on trees. So guys, this is a fully loaded class is what I can tell you, because I have come up with a lot of topics for all of you in this session. So guys, without wasting much of your time, let me get into the session. So in this session, I will be discussing a very important topics with respect to the trees. So I have around 9 different topics here in my agenda. Let me not waste your time by discussing the agenda what I have here. So let me get into the session quickly. So guys, the first topic that I have here is all about the tree representation. When it comes to the tree representation, I can represent it with 2 different ways. The first one is list representation and the second one is I will discuss that. Okay, let's understand what exactly the first one that we have. As I told you, list representation. So if I take this tree, how do I represent this tree in the list form is what I will be discussing with all of you. So guys, so observe this tree what I have here. So what is the first node that I have? I have A. So let me just write A here in the linked list. Alright, so fine. I have A. So for this A, how many child nodes I have? I have 2 child nodes. So fine. So let me just write 2 child nodes here. Alright, so fine. You understood what is that I'm trying to write. So I'm trying to find out how many child nodes for this root node I have. So I have got 2 child nodes, that is B and C. So I'm writing 2 empty boxes for 2 childs. This is for the first child and that is for the second child, that is C. So fine. Then after that, let's start with B. So when it comes to B, so let me just write the B. So guys, this is the reference. So here I will be writing B. Alright. So hope you understood. So this is the reference. I'm writing the B node here. So fine. When it comes to B, how many child nodes I have? So I have got 1, 2, 3. So 3 child nodes I have. So what should I do now? So you all know that what I did, you need to repeat the same thing. You need to create 3 child nodes. That's it. So you will create 3 child nodes. Alright, so fine. 3 child nodes are created now. So then after that, so what is that I have to do? So I have D. So first node D. So should I write D? Yes, you can write D here. Okay. So should I write E? So can I write E? So I cannot write E because E has got the child nodes. He has got the child node. Since whenever you have got the child node, so you will not represent it directly. Instead, you will create one more node like this. Alright, so fine. So after that, you have got E. So let me just write E here. So let me just keep it as it is. Then after that, let me complete this level. What is the next node that I have for B? I have F. That's what you need to remember. So let me finish F. So F has not got any child. So let me keep it as it is. At the end in the reference part, you can just write it as a 0. That is null. So now let me come to the E. So when it comes to E, do I have child nodes? Yes, you all know when I have child node, what is that I have to do? So you will create the nodes. So fine. How many nodes you will create? 2. Alright. So fine. You will create 2 nodes. So when I have 2 nodes, what should I do? Should I create any subnodes like this? No, because I and J has got no child nodes. Let me represent it as it is I and J. So this is how we will be representing the tree. This is how we will be representing the tree with the help of list. Okay, let me show you the complete representation in this. So let me explain this. Sir, why did you explain this here? Because you will get a doubt. So when should I create the nodes like this? When should I have the node like this? You will have a doubt, right? So that's the reason. So I have done that explanation for all of you. Now observe carefully. So how do I represent here? Observe. So I have root node. So I have created root node here. So fine. So after that, what is that next thing that I have to do? I have to create the nodes for this child node. So I have created 2. So one is for B, another one is for C. So fine. Then after that, let me start with B. So B has got 3 child nodes. So first of all, I should write B. So fine, I have done that. How many child node B has got? 3. So let me create 3 boxes. 1, 2, 3. Fine, I have created. So what is the first one that I have? D. So let me write the D as it is. Then after that, E. So can I write the E as it is? No, I cannot write the E as it is because he has got childs. So whenever I have got childs, I will be writing like this. That's what you need to remember. So fine. So let me create an empty box and leave it as it is. Let me not touch this part right now. Then after that, what is the next child that I have? I have F. I will write F, and the next box I will make it as 0. That means it is null. So fine. Then let me come to this box. I have to write E here. So when it comes to E, do I have child nodes for E? Yes. How many child nodes I have? So 2. So what should I do when I have child nodes? I have to create 2 more nodes. So in that, one I will represent it as I, another one is I will represent it as J. So when it comes to the J part, so I don't store any reference or any link. So you have to make it as 0. So this is the first part of the tree. So next part, this is the C part. Alright, so you all know that. So I will be making it as a reference part as 0. So fine. After that, I will write it as C. So you have done that. So C has got child nodes. Yes. How many child nodes I have? 2. What should I do? I will write 2 nodes. That's it. First of all, I should write 2 nodes. I will create that. So after that, should I write G? No, you should not write G because G has got child. So for that, so what you will do is empty box. Below that, you will write G, and then next you will write the K, which is the child of G. Then after that, so the next one, what you have? H. So you will directly write H, and the link part, so you will make it as 0. This is how we represent the tree with respect to the linked list. This is how we need to understand, and this is going to be very, very simple to all of you to understand. All right. So moving forward to the next one that we have, left child, right sibling representation. My dear students, it's very simple and very easy. Or if you find it very complex, I will make it easy. The name itself says that what exactly this representation is all about. Okay, so fine, what is the name? Left child and right sibling. Very simple. You just have to find the left child and right sibling in the entire tree. That's what you need to do. Very simple. Let me just explain. Let me start with a root node. What is your root node? So A is my root node. So fine. So in this root node, what is that you need to find? You need to find the left child. So which one is the left child? So this is the left child and this is the right child. That's what you need to remember. So fine, let me start with the left child. What is that I have? I have B as my left child. So fine, for this left child, which is the right sibling? So C is the right sibling. Sibling in the sense what? So for both A and B, A is the parent. So that's what we call it as a sibling. Right sibling is C. So let me just write it as C. Okay. So let me just take some little extra line. Let me just write it as C. So fine. So that C is a right sibling. That's what you need to remember. So fine. I'm done with A, B, C. Fine. When it comes to next one, so I have the next left child as, so observe, I have D. So fine. Let me just write D. So after that, for D, D is a left child. So for D, which one is the right sibling? So I have E and F. That's what you need to remember. So fine. Let me just write E and then F. That's what you need to observe here. So fine. I'm done with this part. Then when it comes to the next one, do I have the children's for D? No. So what is the next one? So E. I should go to the E. So fine. In the E, which one is the left child? I is the left child. So let me just write that I is a left child. For this I, which one is the right sibling? J is the right sibling. So you just have to write J here. So fine, we have finished this part. The next part that I have here is C. So when it comes to the C, which one is the left child? G is the left child. That's what you need to observe here. So I will write G. So G is the left child. For this G, which one is the right sibling? So H is the right sibling. So you just have to write the H as a sibling. Then I have the last one, that is K. K is the left child. That's what you need to mention it here. So this is how you will be representing any child, any tree with respect to the left child, right sibling. So this is how we do it. So it's very simple again. Okay, I'll just show you. So guys, observe the same thing we have just represented in this format. All right, we have not done anything else. So same thing, we represent it in the form of nodes. That's it. You can use this method. This is going to be very simple for you to remember. Okay, in the notes I have given like this. You don't have to follow this. If you just follow this, this is more easy and very simple to understand, is what I would like to tell you at this point of time. Moving forward to the next topic that I have, binary tree data structure. What exactly binary tree data structure is all about? My dear students, observe and listen to me carefully. What do I call it as a binary tree? So in a tree in which every node can have maximum of 2 children is called as binary tree. Any tree you take it, you take any tree, maximum 2 children. Minimum I can have 0 or 1, but maximum 2. That is what you need to remember. So you need to check the condition here. So this is a node. Maximum how many children I have? I have 2. This is a node. Maximum how many children I have? 2. This is a node. Maximum how many children I have? 2. This is a node. Guys, here I don't have any children at all. So can it be a binary tree? Yes, because 0 and 1. I can also have 0 and 1, but I should not exceed 2 nodes. That is what the condition that you need to remember with respect to the binary tree. I repeat, any node can have 0 or 1 minimum nodes. Maximum, it should have 2. It should not have more than 2 children for any node. That is what you need to remember with respect to the binary tree. So fine, what are the next one that I have? Strictly binary tree. What is the meaning of strictly binary tree? All these things will be asked for 2 marks. So please remember the definition for 2 marks. They will give you this tree and they'll ask you to find out what type of tree it is. So you need to understand. So what is strictly binary tree? Listen to me carefully. A binary tree in which every node has either 2 or 0. It should be 2. It cannot have 1. It should be 2 or it should be 0. That is what you need to check here. So fine. So this is the node. Do I have 2 nodes? Yes, I have 2 nodes. So this is the node. Do I have 2 nodes here? Yes, I have 2 nodes here. This is a node. Do I have 2 nodes? Yes, I have 2 nodes here. So in the same way, observe, this is a node, I have 2 nodes. For this node, I don't have any node. Can it be a strictly binary tree? Yes, of course, because 0 or 2, that is what you need to remember. But when it comes to binary tree, I can also have 1 child node. But here, when it comes to the strictly binary tree, I should not have 1. It should be 0 or 2. That is what you need to remember. Moving forward to the next one, complete binary tree. What happens with the complete binary tree? It's very simple. Guys, a binary tree in which every internal node has got exactly 2 children. For each and every node, internal node, I'm speaking about the internal node in the sense this nodes. Okay, so this is what I will call it as a internal node. So these nodes should have exactly 2 children. That is what I will call it as a completely binary tree. So fine, observe here, I have a root node, so I have got 2 children. So fine, I have got node, I have got 2 children, internal node. This is the internal node. And again, this is the internal node, I have got 2 children. So this is the internal node, I have 2 children. This is the internal node, 2 children. This is the internal node, I have 2 children. This is the again internal node, I have 2 children. That's what you need to remember. But all the leaf nodes are at the same level. When it comes to the leaf node, it should be in the same level. Level in the sense what? So this is 1 level, this is 1 level, this is 1 level, this is 1 level. So all the leaf nodes should be in 1 level. That's what you need to observe here. So that is all about the complete binary tree. So guys, this is one of the important things that you need to remember. Moving forward to the next one, extended binary tree. What exactly extended binary tree is all about? Listen to me carefully. The full binary tree obtained by adding dummy nodes to the binary tree is called extended binary tree. So guys, extended, the name itself says that. So for a binary tree, if you are adding the dummy nodes, okay, so that is what I will call it as a extended binary tree. So observe here, this is the tree that I have. So for this tree, I will add the dummy node here. So for this tree, I will have the dummy node here. So like this, I will be adding the dummy nodes for all the nodes what I have. So that is what I will call it as the extended binary tree. If you are adding the dummy nodes to make that as a binary tree, okay, that is what I will call it as a extended binary tree. Sir, what is that? I need to understand here. I am saying that for a binary tree, you need to understand what is binary tree. So what is binary tree? Observe here. So whenever I say any node which has got 0, 1 or 2, okay, so maximum nodes, it should not exceed more than 2. Okay, so that is what I will call it as a binary tree. So whenever you are adding any dummy nodes to the binary tree, that is what I will call it as a extended binary tree. So that's what you need to remember. First of all, it should satisfy the binary tree. Is it satisfying the binary tree concept? What is the binary tree concept? So it should not exceed more than 2. So observe here, this node I have 2, so it is not exceeding. So observe here. So is it satisfying the binary tree? Yes, because I have 1, it is not exceeding 2. Fine. So till here it is satisfying the binary tree concept. So I will come here. How many children I have? I have 2. Is it satisfying? Yes, because it is having only 2. So again I will come here. So yes, less than 2, no problem. Again here, less than 2, no problem. So this is a binary tree. So for this, I can start extending the nodes. Again, I have to satisfy the binary tree concept there. I should not have more than 2 children for a node. So that's what I need to remember with respect to the extended binary tree. Moving forward to the next one. So guys, binary tree representation. When it comes to the binary tree representation, I can also represent the binary tree using arrays and linked lists. All right, so it's going to be very, very simple and easy. Let me show you how do I represent the tree with a array. This is going to be a very, very interesting topic. Listen to me carefully. Array representation of binary tree. How do I represent this binary tree into array? All right, so that's what we are trying to understand now. So guys, so fine. So let me start with A. So let me just write A in my array. So fine. Imagine this is my beautiful array which I'm going to write. Okay, it's very simple. Fine. I've written that. So then after that, so I have to consider the next level. So this level is done. I have written A. So next level is B. So fine, let me just write B. Then after that, in the same level, I have C. So let me just write C. I'm done with this B and C. Next, I will come to this part. So this part is done. So next part, what I have is this. All right. So fine. What is that I have in this level? So I have D. So fine, I have written D. Then next, in this level, what is the next one? I have F. That's what you need to write. And then, so in the same level, I have G and then I have H. Observe here. So this level is done completely. Moving forward to the next level that I have. So what is the next level? What is that I have in this level? I have A. Is it A? I. Listen to me carefully. All right. So I have I. Then after that, I have J. So fine, I'm done. So, but for this also, I should have 2, right? So for that reason, what I will be doing is, I will be leaving 2 empty. All right. So when it comes to G, so I should also have the left child, right? Which I'm not having. So for that also I'm leaving it empty. Then after that I have K. So let me write K. Then after that for this H, I should leave it empty. So fine. So for this H also it is empty. So I'm leaving it empty. This is how I will be representing the binary tree into array format. All right. So hope all of you are finding it easy. Right. Moving forward to the next topic that I have. Linked list representation of binary tree. It's going to be very simple. So same tree what you have here, you consider the same tree. All right. So in the left child address in the left part. So in middle, you should maintain the data in the right side part. So guys, you will mention the right child address. That's it. It's very simple. So guys, if this is the node, so what is that you will create? So you will have the node like this. So this left child address, you will store it here, and this right child address, you will store it here. In the middle part, you will have the A. That's it. So you'll not do anything else. For this also, same thing. Okay. If you just write like this, finished. All right. So this is how easily you can convert. All right. So for this also, observe here. So what is there any difference? No, you're just having the connection here. That's it. So you're not doing anything else. So whenever you find it like, you don't have any address, you just have to replace it with null. That's what you have to do. So let me explain the concept to all of you once again. So guys, I have A. So I'm writing A in the data part. So fine. In these 2 parts, right now it is empty. So what should I mention in the left side? I should mention the address of the left child. So that is what I will be writing. So fine. writing or I'm filling the address of the left child. So after that, so here in this part, address of the right child. That's what I'm doing here. So fine. What are the next left side left child that I have? I have B. So fine. Let me write B here. Again, for B, I have two children, that is D and F. So here I will be mentioning the address of the left child. I'll be mentioning the address of the right child. So the left child is D. So right child is F for B. That's what you need to observe here. So fine. After D, observe D has got two children, that is I and J. So fine. Let me write the address here, the left child address, right side address. Alright, so fine. When it comes to I don't have any children for I. So for that reason, here I will mention null. That's what you need to observe here. Same thing happens with the J. So J also does not have any children. So that's the reason I will mention the null in both the right and left side. That's what you need to observe here. So fine. This part we have finished. Okay. When it comes to F, again, F does not contain any children. I will fill it with the null. So same thing happens here also. I have got C. C has got two children, that is G and A. So A does not have any children. I will fill it with null. So G has got one children, that is right children. So the address of right children, I will mention it here. And when it comes to K, K does not have any children. So I will fill the null. Here also, I will fill the null because G does not contain any left children. This is how I will be representing the tree with a linked list. Moving forward to the next and an important thing, you will be getting this in your exam. Okay, 5 marks. Or you can also expect it for 7 marks. This is going to be very, very, very important. A lot of people teaches you in a different way. Okay, so this concept will also come for your competitive exams. Say for example, if you are writing a PGCET or any competitive exams, this question will be asked. You should not take more time to remember this. Okay, so I will show you one of the best trick to write all the 3 order traversing. Traversing in the sense visiting each and every element that you have in the tree. So we have 3 different types of traversing. One is in order, pre-order and post-order. This is what you need to remember. In order, pre-order, post-order. Today, I'm going to show you one of the simplest method and easy trick to remember or to write the answer quickly. Alright, so guys, imagine this is my tree that I have and this is the answer. If I convert this tree into pre-order, I should get this answer. If I convert this tree into in order, I should get this answer. If I convert this tree into post order, I should get this answer. Alright, how do I get this answer? I will teach you one of the trick. So guys, whenever I'm visiting to that particular node for the first time, so that node should go to the pre-order. First time if you're visiting that node, it should go to the pre-order. Second time if you're visiting, so it should go to the in order. Third time if you're visiting, it should go to the post order. This is what you need to remember. I repeat, if you are going for the first time to that particular node, it should go to the pre-order. Second time if it is going, it should go to the in order. Third time if it is going, it should go to the post order. That's what you need to remember. Very simple. Okay, let me show you how exactly it happens. Let me start with the root node. Am I coming to this node for the first time? Yes, I'm coming to this for the first time. So guys, let me just write here. So pre-order. Okay, let me write it as pre-order. So pre-order, let me finish writing in order and then post order. Okay, so post order. So I will match the answer later. All right, so fine. So first time you are coming to the A. So first time in the sense to which one it should go. So it should go to the pre-order. So fine, A I've written. So observe here, I got A. All right, so fine. After this, I'll start traversing. So first time I'm visiting. Am I coming to B for the first time? Yes. So it should go to pre-order because it is coming for the first time. So fine, observe here, I got B. After that, I will come to D. So am I coming for the first time? Yes, right then. So for the pre-order. So I also got the D. Alright, so fine. After that, I'm coming to the I for the first time. So I will write I after D. So do I have I? Yes, I have. The answer is correct. Correct? So fine. After that, so guys, let me show you one more thing. For each and every node, so you have to write like this. You have to create the children like this. So already I have right children. So I have to have the left children. So for this also, 2 children. And for this also 2 children. Like this, you just keep it ready. Alright, so fine. I have, right now I am in the I. So fine. I will come and I will visit again. I will visit again since I don't have any children here. So directly I'll come back to the I. So this is the second time that I'm coming to the I, because first time is this one, second time is this one, right? So if it is second time, to which one it should go? It should go to the in order. So first write it here, I. So do I have I in the in order? Yes, I have I in the in order. Cool. Then after that, again, you have one more node, right, which you don't have. So again, you will come back here. So you will come back to the I one more time. So this is the third time that you are visiting the I. So fine, if it is the third time, it should go to the post order. Write the I here. Do I have the I here? Yes, you have the I here. So cool. Then move back to the D. So you are coming to the D for the second time. Second time in the sense where you should write. So you should write it in the in order. So fine, I will write D here in the in order. Do I have D here after I? Yes, my answer is correct. So fine. After that, I will travel back here. So you are coming to the J. For the first time? Yes, for the first time. First time in the sense it should go to the pre-order. After I, do I have J? Yes, correct. So then after that, so guys, you will come back here and then here you will come. Okay. So you are coming to this J for the second time. Second time in the sense what? So it should go to the in order. So I have to write it to the in order. So observe D, I, D, J. So fine, we are done with that. So after that, so you will come back to J again. So this is the third time you are coming back to the J. Third time in the sense post order. So I, J. Observe I, J. That's what I have here. So fine. After that, you are coming back to the D. So guys, how many times you have come back to the D? This is the first time. Again, this is the second time. This is the third time. Third time in the sense post order. I will write D. So do I have D here? Correct. I have D. So fine. After that, so move back. So guys, you are coming back to the D. How many times you are coming back to the D? This is the second time. This is the first time and this is the second time. Second time in the sense you have to write it in the in order. Do I have B? Yes, I have B. All right, moving forward to the next one. So from here, I will start my journey. Okay. So I'm coming to the F. Are you coming for the first time? Yes, I'm coming for the first time. So where should I write? Pre-order. So let me write F here. Do I have F after J? Exactly. All right. So fine. After that, so I will come here. Okay. So are you coming for the first time? No. This is the second time I'm coming for the F. So second time F in the sense F should go to the in order. After B, I should write F. Do I have F after B? Yes. So fine. After that, then again you will come back. So third time you are coming for the F. So it should go to the post order. It should go to the post order. Observe here F. Cool. Understood? Then after that, so guys, you are coming back to the B. You are coming back to the B. This is the first time. This is the second time. This is the third time. So you are coming to the B. So third time in the sense pre-order. So that's what you need to remember. After F, it is B. Observe. All right. So fine. So from here, you are coming to the A. So A, this is the first time you have already come. So this is the second time. Second time in the sense in order. After A, F, you will write A. Observe here. After F, I have A. So fine. Then after that, I'm coming to C. I'm coming to the C for the first time. So let me write C here. So do I have C here? Yes. And then after that, I'm coming to G for the first time. So should I write it in the pre-order? Yes. Observe G. All right. Then after that, so I'm coming to this G for the second time. Second time in the sense in order. Observe after A, I should have G. Yes, I have G. All right. So then after that, so I'll come to the K. K, you're coming for the first time. So come first time in the sense it should go to the pre-order. After G, I will write K. Should I have K? Yes. Then after that, so guys, this is what you need to remember. So what should I do here? I'm here. So after that, so guys, I will write G. So now I am in the K for the first time. Then after that, so guys, what happens? I will come back to the K. How many times am I coming back to the K? Second time I'm coming back to the K. If it is second time, so guys, where should I go? So it should go to the in order. So guys, observe here, after G, I have K. So that's what I will mention it here. So fine. After that, so guys, again, I will come back to the K for the third time. If it is coming for the third time, so I should mention it here. So after B, again, I will have K. So that's what I have here. So fine, I'm done. Then after that, so guys, I'll come back to the G. How many times I'm coming back to the G? So this is the first time, this is the second time, this is the third time. Third time in the sense after K, it should be G, correct? So I have G. So fine, moving back to the C. Moving back to the C. How many times you have gone to the C? This is the first time and this is the second time. Second time in the sense, it should be in order. So after K, it should be C. So that's what I have here. So I will mention it here. So that's what you need to remember. So fine. Then after that, from here, you are coming to the H. So how many times you have come to the H? For the first time. First time in the sense, I will write H after K. Do I have H? Yes, you have already got the pre-order. Okay, the same correct answer you have got. So fine. After that, so you will come here. Then this is the second time you are visiting the H. Second time in the sense, you should write it in order. So fine. After C, I will write the H. Do I have H? Yes, I've got the in order also completely. The next, again, I will visit the H here. Okay. So how many times you are visiting? Third time. So third time in the sense post order. Okay. Then after that, so I got the H. Then I will come to the C here. C. So how many times you are coming to the C? This is the first time. This is the second time. This is the third time. Obviously, so you should mention it in the post order. So fine. Then after that, you are coming to the A. So this is the first time, this is the second time, this is the third time. Third time in the sense, you have to mention it in the post order. So you got C and A. So guys, this is the answer, exact answer. So this is the answer that I have got with my tricks. Okay, both are matching. This is very simple, so you will not make any mistake. So this is what you need to remember to understand or to find out pre-order, post-order, in order. So you will get easily 7 marks. Easily you will be able to score 7 marks without making any mistake. Alright. So the only thing that you need to remember is whenever you got any tree, for each and every tree, you should make sure that you should have 2 nodes. Okay. Suppose if you don't have that, so you just have to create like this. Okay. For all the nodes. For all the nodes, whatever you have given. So for this, do I have 2? Yes, I have 2. So for this, do I have 2? Yes. So for this, yes. So like this, so you should make sure that all the nodes has got 2. So if you are done with this, rest everything is simple. So remember the trick, okay? Pre-order in the sense, first visit, okay? First visit, you will write the pre-order. Second visit, you will write the in order. Third visit, you will write the post order. If you remember this, you are done with the traversing. So let me make it very simple to all of you. So with this, I've come to an end of this session. Thank you. Bye-bye.